What's up, guys? Welcome back to the channel. Today on this video we'll be doing the following two problems that you see here. I'm gonna add another one, so watch this video to the end. So on this video we'll be converting the complex numbers from polar to rectangular form. So before I start, how about you pause this video, do these two problems, and let's see if you can able to get the correct answer. All right, so before I start solving this, I just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel, and don't forget to share the videos as well. All right, guys, so what is happening here? You are given these two problems here, and these problems are complex numbers which are in the form of polar, both of them. Just in case you don't understand this polar form, you can go to the description. I left a video where I explain this polar form, and that video will also pop up on the top right of this video. Now let's look at number one. We have the square root of 2 multiplied by cos 45 multiplied by imaginary sine 45. This here is another form or notation of the polar form. So in order for us to change this to the rectangular, you just have to use your calculator here. So let's continue. The modulus, which is root 2, you just write it as root 2. Then from there, you just use a calculator. What is cos 45? If you use a calculator, it's going to give you root 2 over 2 plus imaginary number. Don't forget, we have imaginary number here. And then when you put your calculator again on sine 45, you're going to give you the same thing, which is going to be root 2 over 2. Now, all you have to do here is just remove the bracket by multiplying with root 2. So if you multiply with root 2 throughout, the first one here is going to give you 1 plus, and then the second one, the second term here is gonna give you 1 multiplied by I. So this, it's actually how you change from polar to rectangular. Don't forget, guys, rectangular has a real number and imaginary number. Just in case you don't know the rectangular form, I already made a video on the rectangular form. Go to the description. Again, I left an example or a video where I explain the introduction of the rectangular form. Now let's do number 2. So number 2, as you can see now, it is given in a different notation. It's the same as this one, guys. It's just that you need to add an extra step. So when you continue with number 2, you're going to have root 3, and then you open the bracket. Now inside there, you're going to have cos. Now look, this 60 here is actually theta or argument plus imaginary number, and then you're gonna have sine 60 degrees. So the extra step that I was talking about, it's similar to what is given to you there. Then from there, you start using your calculator. Obviously, you're gonna have root 3, and then you put cos 60 on your calculator. So cos 60 is 1 over 2, which is half, plus imaginary number. Then you put sine 60 on your calculator, which is gonna give you root 3 over 2. Then from there, all you have to do is just multiply by this root 3 outside, and then you're gonna have root 3 over 2 plus imaginary number, and then 3 over 2. You can leave it like this. It's fine, guys. As you can see, this is how you change from polar to rectangular. Do not forget, guys, the rectangular notation is a real number plus imaginary number, like that. So as you can see, our real number is here and our imaginary number is there. All right, guys, so let me add the last notation of the polar form. So let's make this one number 3. You can be given a problem like this. Maybe we have 2, and then we have 6, and then let's say this is 30. Guys, this here is still the polar form. It's another notation to show that this is a polar form. Now, this says here, it's actually an abbreviation for cos, imaginary, and sine. As you can see, we have cos, imaginary, and sign. Just in case you come across this, just remember this is still the polar form. As you can see here, the 2 here represent the modulus and the 30 represent the argument, which is in degrees. So this one here, you can also, when you change it into rectangular, you can take this 2 here outside and then cos 30 degrees plus imaginary number, then sine 30 degrees. Now you use your calculator to get your cos 30. So let's not forget this is going to be 2. So cos 30 is going to be root 3 over 2 plus imaginary, and then our sine 30 is going to be 1 over 2. Then if you get rid of the bracket, you must multiply by these 2 outside, and then you will have your final answer as root 3 plus imaginary number. So this here, guys, it's how you also change from the polar form, this one here, to rectangular form. Guys, I hope you managed to understand this, because this was not really that difficult. If it so happened that you didn't understand, go back to the point where you didn't understand, rewatch at that point, or ask a question on the comment section. I'll try to answer you to my level best. All right, guys, if it so happened that you watch these videos and you haven't subscribed to the channel, subscribe to the channel. Don't forget to like this video if it really helped you to understand. Thank you very much, guys, for watching. Till next time, cheers.